So the next thing I would like to show you is how I log. Actually found a really quite smart implementation sometime in the past that someone did using the logR's package, and I have always implemented my logging in that fashion. And I would of course quickly show you. So here inside our log file, I'm going to create called go, and this will be of course package log. And I think this is a really smart approach to this tool, and that's also what I'm doing here. So I'll define a tab. So this will contain the message that we want to return to the user. So it's going to be a map of strings and interface. And of course, we have to define a type for our level, or log level, which will be an unsigned int32. And we define some constants. So we define a level, trace, iota, and then say level, which will be our, of course, log levels. So level info, level 1, level error, level failure, and level parent. And the next thing I want to define the function and set output. It takes an IO writer and now of course we create this package. Let's set output, takes a writer, and of course it should be calculator, and of course I can just copy the URL to the package, and then we have it installed. We install it, and so go mod ID. So we should have it installed now. Did I spell this? Set output, and of course. And now we define that is unused, okay. And now we define our another function to set the log level. So it should be able to take a level of that level, and now we actually need to match the level. So we and of course it should be var, and we switch of course based on this value. So level that we receive, and say yes. So when it is trace, our L would become first, that's info to the trace level first, and this is actually what we need to do for the cases. So when it is info, our log level will become log info level, and we have to do this for them actually. So level 1, so it's 1, L becomes RS 1 level, and error, or L becomes error level. And yep, when the level is of course fatal, becomes local alt fatal, and I think the last should be panic. Now it become panic level, and of course we now let's set the level to that's what sorry, and that's what needs to happen. And the next thing that we need to do, of course I can make this so that the next thing we need to do is now to define the functions for all the log levels. So we need to take a message of type string and args of type m, and it's going to return arrays for the fields, and take the log characters, the fields, we'll pass the args, and of course because this is info, we pass the message this way. And this is what we need to do for this is also what we need to do for the log levels. So we have info, we have debug, we have warn, we have error, we have trace, we have fatal, and we have I think that's it for now. So we can call this debug. So of course this would become debug, and that's all that needs to change. And this would be 1, this would be 1, then this would be error, and this would be trace, maybe trace, and this would be fatal, and this of course would be fatal. And we didn't need this one more actually, and maybe I define an init method. So from init it returns, it simply says the log level for us. Level introduce to trace, and I think that's mostly it. Yeah, so that's what I wanted to show you in this section. And while we progress, we can of course already use this. So if we wanted to maybe use that in here, we could actually look to our info, and then maybe here we pass some message and say that was error on March, and by this guy here we can actually add more information. It's the error, let's go to this error, and something like this. Do we have this guy? Something like this is how we could use this, and maybe this would now be error. So this would actually be something we could use in place of using, let's say, fmt print or fmt print line. So we can use this to give our logs nice formatting. So now let's define our APIs. So we can move over here. Right now it's still empty, but we're going to fill that up quite quickly. And so I'd like to have our main file called API.go. API. And now I would like to define also try to define some files with it. So we talked about handling users and accounts. So I want to have one for accounts and pro. I'm always hitting the plus button in place of enter key. So package API, and I want to create one for users. API, and I also want to create one for our documentation. Tony API, and I want to maybe add one for some miss parts. And what I can quickly also do is to come to our handlers, create a new folder called miss. And inside of here, I can define the health endpoint. That's something I know I can already quickly do. And it's really going to be pretty simple. So we have a func health. It's going to have, of course, signature like the rest. So it takes a pointer to a gene context, and it's only just going to do one thing basically. It's just going to return to the user. C.json, and we can return here HTTP. It's okay. And we can return some message in the header. And we can say something like message healthy. And I think that's mostly what we needed to do over here. So the next thing we'd want to do now is to actually define our APIs. So we can start with this our miss endpoint. And I can give it something like, let's say, miss routes. So it's going to take a pointer to a gene engine, and it's going to take a version. It's version string, and it of course doesn't need to return anything. So I would like to group all of these anyway. So from the engine, I can create a group, and I would like to always version my APIs this way. So this V could actually be, say, V1 from the version, and so it will be V1 / let's say miss. And now I can use this to define my endpoint. So I can call this /health. So in the end, it's going to be, let's say if the version is V1, it's going to be /V1/miss/health. And here I need to provide the handler. So it's miss.health. And that's actually what I need to do. I don't need to invoke the function. It should be like this. So this is really fine. And then I go back to, I can actually copy this. I can copy this and go to account. Paste them into handlers. I'll go to accounts. Now I'll call this need add account routes, and of course I don't need another health endpoint. So I can call this accounts, and here we had defined a couple of endpoints, so I could say, we could, let's say, get an account and call this /cc, I don't know, and I can say get account. So if I go quickly here, I want to confirm. So we have get account and get accounts. So those are two, and of course here I want it to be accounts. And I want to copy the same thing, put in here. So, and this would be, I'll provide an ID. Let's get an ID in the path, and this would be to get that a single account. And of course, we have defined a post method, and I can maybe call this create. So this would be create account with create account, awesome. And I define a put. The put we can say is CS / the ID counts update accounts, awesome. And one last but not the least is our delete endpoint. So it should of course be SCCS. Let's say a delete, and then we provide an ID and we use this endpoint. And so this is mostly it for accounts, and we can also do the same for users. And we of course change the name to add users routes. So this we can change of course to users. Fortunately, I'm not able to spell users today. So users, and maybe to get our users, we can say users. And we of course change this to users, and this one would also be maybe user / ID, and it's user, and it creates. I'm gonna leave it as it is. Let's create user. What else? So the user / ID to create a user, and this would be update account. No. Update user, and then last but not the least, some of the users update user. So this should be fine. And maybe what I can also already do is, so if for all this, if you think of this for all these endpoints, we probably would need to manipulate data on the database. So what we could do, at least for all these endpoints, and what we could do is to maybe on this level, we can already add the middleware. The authentication, we could add here, I don't know, what could we put here? No, here we can already put our Postgres middleware, for example. And we can also do the same for our users. Sorry, should be this time. We have it for users, so put it for accounts. And so what it means is for each of these endpoints, this middleware would be applied. So they would have access to this Postgres client, and we can actually make queries against the database depending on the credentials we've provided for the database. And that's why we have this over here. What now needs to happen is, of course, we need to do something similar for our documentation. And of course, I'm also going to show you how that would need to look in the end. And I can call this add Swagger routes, and of course it should take the same format. And I can put it in /swagger, and I can make this any, doesn't matter, it would match anything. And so should not be this. So this will take from jeans Swagger, go to wrap and handler, and then we provide Swagger files that handle. We need to do a couple of imports, so I can run these Swagger files. No. Our Swagger files would come from github.com swagger files, and our gene Swagger would come from github.com/swagger/gene Swagger. And I think this let's go to this, so we'll go mod tidy. What we actually now need to do is to now define more or less bring everything together, and that's what would now happen in this the main API file. So here I like to define type for my API, because it's a struct and it would only have two items. One would be the engine, which would be a pointer to engine, and the next would be a server, which would be a pointer to HTTP server. And yeah, so now what needs to happen is we need to define a couple of methods on this API. So the first function, of course, I'll call this the first function I would like to define is an init method. So the init method takes a version, which is a string, and it returns two things. It returns either a pointer to an engine, or it returns an error. So now, of course, this is where we initialize our server, gene server basically. So gene.new and gene.use it's on, and of course we want to use recovery. So when we panic, we want to recover, and we also want to use gene logger. And this is where we now decide the mode we are running on, so we can use the helper function we wrote earlier. Will help us get env, and we call this mode, I think. So if this is release, we are running this in release mode, we would like to set the gene mode to release mode, and we can maybe just log something to the user so we know what's going on, and we can say something like running on release mode. But if that's not the case, we simply we are running in debug mode anyways, so we simply say running on debug mode, and what we try to do here is to be sure that we have the app env file. So if you are running debug mode, and we assume you're doing local development. If you're doing local development, you should have this env file. So it's a go.env. Let's load and provide the name of the file. Set it to be called app.env. And say if is not nil. So if some error occurred, actually we want to return nil for engine and error. So let's continue with our setup. So at this point, we would have handled the presence of our env files. So we set our engine to R, which is what we of course initialized here. And this is where we use some default middlewares. So we can actually just dump. We can actually just do something like how do I use middleware, and we say middleware dot I don't know, maybe cause something like this. But what I would like to do is to just define a new function that's going to do that for us. So it's still going to exist on our API. So another receiver function, we can say something like with middlewares. Still going to take a version of that string, and it's going to return a bunch of middlewares, which simply just have our signature that we define for our middlewares. And then here we simply return every other thing. So what we are trying to do here is to make sure that on the topmost level, we want to define the middlewares that should always be present. It doesn't matter if it's an authenticated or an unauthenticated endpoint. We want to define middlewares that would always be there. And here we could have a cause middleware, for example, and maybe I can also throw in the config middleware. And so, like I explained, this is the idea. And if you're doing this, you can again decide how best you want to go about this. So here we can say a.middlewares, and then we can also provide a version, and this is fine. So we have added a version, and the next thing I would like to do is to add routes, of course. And I would, instead of also adding this individually, I would again define the function. Call this, it's going to of course be receiver function for our API struct, and I can call this add routes. And again, it's going to take a version, which is a string, and it's going to it will not return anything, because when we defined our middlewares, they were actually not returning anything. So here we define a bunch of routes. So here we can say add account routes. We provide the engine, and we provide version. And here we can also add user routes. Again, we provide the engine and provide the version. What else we had for our miss endpoint? We provide the engine and version. And again, last but not the least would be to add for swagger routes. We provide the engine and we provide the version. Now, so here what we can now do is to say add routes and provide version in itself. So we are structuring this in such a way that when we initialize, we have all of this, and if anything changes, we know we just have to update it once place. So if we want to take out these routes, all we need to do is actually comment this out, and they will no longer be built when this code is compiled. So if let's say we are working with Postgres, we might be needing to maybe run some migrations. So this is where actually we can accommodate that by saying make migrations, and we could say post. Right, and this could be where we make our migration. So I can just put a message here and say making migrations for the Postgres database. And I could also copy it, and let's say we talked about having SQL, and we can also put that in here. I would say for SQL database, so we're making migrations for it. And so the next thing we'd want to define also is setting up our server, and this is also where, because we get to define, let's say, the ports we want our server to run on. Like I said, I really want to have all this separate, and I could call this with server, and it's just going to return an API struct. So here we initialize the channel, and we make a channel. Come on. API, and then we define a function. Of course, this would run asynchronously. So we say the server. We define, of course, like I said, what our server needs to be. So this will be a server, and we define some information here. So address. We could do this. Okay, let's a little bit fancy. So make this print f, and here we need to. So this would also allow, if we are reading this from our env file, we could provide this way, but now we can say 8080, and we need to define a handler. Our handler will be our engine, and we can also maybe read header timeout, state the duration. We can just make it 100. Should be fine. And of course, we read from this channel. Read from the channel, and of course, we need to put this up. It should be this way. And we return what we're reading from this channel, and this should be it. So this would be our server. So this would be one way we initialize our server. So what we can now do is we come over here and we say with server, and that would be done. And what we can also do already is migrations. We can make migrations here for both Postgres and of course SQL. And at this point we can just return if we don't have any errors at this point. So why is we have to tidy, install packages that are not yet installed, and that should be fine now. And now we need to define one more function to actually start the whole process. So I'll of course name it start. So the start would take the gene engine, and it would return void. So I would try to define here parallel function that's going to initialize our server for us. And I need to close this off here, actually invoking it. And this is where I initialize our server. So that server, let's list and serve. And if there is an error, and this error is not equal to nil, if there is an actual error, and if this error is also not equal to HTTP. Error server closed is what I'm looking for. Error server closed. If it's neither of both, then here I wanna let's log and make F. That's what I'm looking for. Let's see if that's important for me. I'm say listing, and I'm just gonna supply. I want it to go to a new line. I'm just gonna supply the like this. And so here also I would like to define what happens or how our server shuts down. And I would like to also make a channel. It will be OS signal. And of course I have to save so it imports the OS for us. And the size of course would be 1. And define a couple of things. So signal.notify, yeah, it's wait, and this is call dot signet. I think this should be here, of course. Complete. And we also, of course, we need to import call. So this should be, if I'm not mistaken. Oh no, signet, not init. So it should be like this. Maybe here I can also define I will define the logic as to how our server can gracefully shut down. So we will try to shut it down, and we also of course observe if everything went well. So context that with timeout, I will of course pass context the background, and we say maybe time dot second. So we say 2 seconds. That for me. Of course, we declare counter to the end. Now we can say if error edit server shut down, try to shut down. I'll provide the context. I'll check that the error is not new. So if the error is not new, we panic. And I'll just kind of line, and let's say maybe server shutting down. That's my error, and of course I need to, I think this part is getting long and I don't want it to be really long, and then I can just maybe put in some message here. Let's say visiting server. So of course I can use FMT here. Line. So this would be our start function, and I think that's actually all we need. And then maybe I need to add a function to actually start the whole process. So I'll have a new function down here. So I will provide API version, which will be a string. It will return API. So initialize the API this way. API and channel the API this way. So, and we now try to, of course, use all the methods we define above. We'll say API.init, and we provide the API version. We'll say if this error is not equal to me in email, we panic with the error. And if everything goes well, we append our engine. Our engine becomes R, and we return API. And I think that's mostly what we need. So what we need to do next is actually to go to our main function and then hook everything up, and we test it out. So we can come back in here to our main, and we can do some cleanup. So here I can define our constants, our API version. For now, we can call this version 1. And so here we need to define our API. So API is new, and we need to cancel. So we initialize our API this way, and now all we need to do is start, and we provide our engine. And that's actually all we need to do in here. And maybe we can just put some messages. So instead of print hello world, we get rid of this, and we can use the function we created here. So that's in server, and provide some more metadata, some information, and we could say success. We already started it, and you can say API version. API version will be our API version. Put a comma there, and then this should be it. So we can now get rid of this actually. And what we can now try to do is to run our function and see if everything is as it should be. So if we look down here, it seems that we are able to, we can see all our endpoints, and to quickly see if everything is working, we can test out at least, let's say the health endpoint. So we can go to localhost 8080, we'll go to v1, miss health, and this is fine. So this is actually working well, as you can see, guys, and everything looks okay. We also get our 200 over here, and so it seems everything is working quite well. So what I would like to do next is say a little bit, a couple of things about how documentation could happen, and of course how you could write tests. These are like really huge topics, but I'll try as much as I can to quickly brush over them, and so you can always have this as a reference and can always come back to it in the future if you would want to. And then after that, I'll summarize, and we can call it a day.